Good morning, students. In the last class, we have learned especially about theorem 6.4. Have you remembered that? The ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding sides. So, in the last class, I gave some homework, and after that, those students have submitted their homework. I saw all of them correct. That is good result. Today, I am going to give you question number 3, 4, and 7 from this exercise 6.4. And other questions you can solve easily. Already we have solved question number 1 and 2. See question number 3 now. In the figure, ABC and DBC are two triangles on the same base BC. See, this is the base BC. AB, ABC and DBC on the same base BC are having two triangles. If AD intersect BC at O, this is O, AD intersect BC at O, so that area of ABC by area of DBC is equal to AO by DO. You need to prove this relation. Understood? See, here you write first, we have ABC and DBC are two triangles. Clear? Draw, see, since these two triangles on the same base BC, draw AM perpendicular to BC and DN perpendicular to BC. See, you have to draw two perpendiculars on the side BC, okay? Because BC is the common side of triangle ABC and DBC. Now see, what do we need? Area of ABC by area of DBC. Now, first you write this construction part. Draw AM perpendicular to BC and also what? DN perpendicular to BC. Now, area of ABC, this is triangle ABC, by area of triangle DBC is equal to what? You can write, see, as we know that the area of a triangle is what? Having to base into height. So in the triangle ABC, you can see the base is BC and height this perpendicular AM. Next, in the triangle DBC, what is base? Same base BC and height DN. Then half BC cancel out. And what is left? AM by DN. This one we got. Okay, next. See, these two triangles, triangle AOM and triangle DON. In triangle AON, because the corresponding angle is D, and triangle what? DON. That is why I am writing AON and DON. Then angle AOM, this is AOM, is equal to angle DON. Why? Because vertically opposite angle. These two angles are what? Vertically opposite angle. Next, angle AMO is equal to angle DNO. Why? It's 90 degree. So using AA, triangle AMO similar triangle DNO. These two triangles similar, so we can get all the corresponding angles are equal, and also all the sides are in the same ratio. That means you can write AM, this is AM, okay, AM, then DN, MO by DO is equal to, sorry, MO by NO. This is N, not DO, this is NO, MO by NO, and AO by DO. This relation we got. Now here, I need to prove triangle ABC, area of triangle ABC by area of triangle ABC by area of triangle DBC is equal to AO by DO. See, and already we have area of triangle ABC by area of triangle DBC what? AM by DM, and this AM by DN is equal to what? AO by DO. So we can replace this AM by DN by what? AO by DO. Then we will get the result. So this is number 1, and this is number 2. So you can write now. There is no place on the right hand side. That is, I am writing this side. You write continuously, okay? Then from 1 and what? 2. What will get? Area of ABC by area of DBC is equal to, just replace AM by DN by what? AO by DO. AO by DO. Proved. Okay. Next. Question number 4. If the areas of two similar triangles are equal, prove that they are congruent. Is it correct? That one we are going to prove, no? It is correct or not? 100% it is correct, okay? So how to prove that if the areas of two similar triangles are equal, two similar, then they are congruent, okay? See. So you have to give little introduction. Let ABC and PQR are two similar triangles. Clear? Now, since they are similar, and also according to the question what they have said, areas are equal. Also, area of ABC is equal to what? Area of DBC. See, if you transfer this whole area of DBC this side, see, you can transfer this one in two ways. If you transfer directly, then you will get area of ABC minus area of DBC. But if you transfer like this way, see, area of ABC by area of what? Because there is single area of DBC only. DBC what you will get is equal to 1. It is, now we see, now the question is it balance or not? If you cross multiply, there is a 1. So ABC into area of ABC into 1, area of ABC, area of DBC into 1. So it is balance. You can write. Means area of ABC by area of DBC, the ratio is what? Is equal to what? 1. This is one number. Again, already they have given these two triangles are similar, ABC and PQR. So you can write what? All the corresponding sides are in the same ratio. Means AB by what? Or directly you can do this one using the theorem 6.6, that if two triangles are similar, then their ratio of the areas like that, means area of ABC, because they are similar, by area of what? PQR, what you can write? AB by PQ whole square, then BC by QR whole square corresponding sides, and at last AC by PR whole square. We are using the theorem. Ratio of the two similar triangles, the areas of the ratio of two similar triangles is equal to this one. Now, the value of area of ABC by area of PQR is what? In one number? 1. So you can put 1 here. Then AB by PQ whole square, BC by QR whole square, and AC by PR whole square. Okay, now compare. Like that means 1 is equal to what? AB by BQ whole square also. 1 is equal to BC by QR whole square. 1 is equal to AC by PR whole square. Now you can write like that. No, 1 is equal to, separately write AB by PQ whole square. Yes or no? You can write like that. If 1 is equal to AB by PQ whole square, then can you balance it like that? You can write 1 square. Yes or no? Then AB by PQ whole square. Now square both side cancel. I am writing here. And what is left? 1 is equal to what? AB by PQ. If you cross multiply, then you will get what? AB is equal to PQ. So when you are taking separately 1 is equal to AB by PQ whole square, then what you will get? AB by PQ. If you take 1 is equal to BC by QR whole square, you will get what? BC by QR. If you write 1 is equal to AC by PR whole square, then you will get AC is equal to PR. That means similarly we will get BC is equal to QR and AC is equal to PR. So now all the sides are equal. What? Now in triangle ABC and PQR, all the sides are equal or not? Just now we have proved this is ABC, means we got AB is equal to PQ, BC is equal to what? QR, and AC is equal to PR. So try to remember congruent criteria. What? Using SSS triangle ABC similar triangle PQR. Clear? Sorry, not similar. Triangle ABC congruent triangle PQR. So we have proved if the areas of two similar triangles are equal, then they are congruent. Question number 7. Now question number 7. Prove that the area of an equilateral triangle described of one side of a square is equal to half the area of the equilateral triangle described of one of its diagonal. That means I know you did not understand this question. So try to understand. I'm going to draw a figure. Area of equilateral triangle described on one side of a square. Suppose you are having a square. This one. This is a square. A, B, C, D. Now read the question. Area of an equilateral triangle described of one side of a square. You have to draw equilateral triangle by taking the measurement of any of the side of this square. Suppose I am taking DC. DC. So this is E. This is equilateral triangle. Is equal to half the area of the equilateral triangle described of one of its diagonal. Suppose I am drawing this one. I am drawing a diagonal AC. Now by taking measurement AC, you have to draw one more equilateral triangle. Sorry, this is okay. This line is wrong. So this is F. Now what need to prove? We need to prove that the area of this triangle described on the side is half the area of this triangle ACF described on the diagonal. Means area of this triangle is half of this triangle. What we are getting on the diagonal. Okay. See. Let ABCD is a square. Okay. According to question, DC and ACF are two equilateral triangles. Now we can say that DEC and ACF similar. Why? Because all the equilateral triangles are similar. Since they have measurement of each angle is how much? 60 degree. So using A, you can say that all the equilateral triangles are similar. Understood? We know that all the equilateral triangles are similar. If all the equilateral triangles are similar, then you can say that triangle DEC and triangle ACF are also similar. Or triangle DC, okay. You have to write in order corresponding. That's what DC. So triangle DC similar is the triangle what? CF. Because all the equilateral triangles are similar. So if they are similar, then what? We can use theorem 6.6. So using theorem, we can write what? Area of DCE by area of ACF is equal to what? DC by AC whole square, or C by CF whole square. Anyone, I am taking this because the DC is the side of the square and AC is the what? Diagonal. That is why I am taking this pair only. Okay. By taking this pair only, you can get the proof. So now DC and AC, we need to show that area of DC is half of area of what? ACF. Now DC is the side of the square and AC is the diagonal of the square. So now we have to find out what is the relation of a side of a square is with the diagonal of a square. The relation between the side of the square and the diagonal of the square. See, I'll give you a little explanation here. As we know that in a square all the angles how much? 90 degree. All of you know this. Then ADC is what? ADC what? Right angle triangle. If you use Pythagoras theorem here, then you will get AC square equal to what? AD square plus DC square. Now AC square, see, AD, DC, these are the sides of a triangle of the square. AD, DC, BC and AB. Maybe this one looking like a rectangle, but sorry, because I have drawn here without scale. But ABC, DC is square, okay. Means square means all the sides are equal. Means AB is equal to BC, BC is equal to CD, CD is equal to AD. So here AD and DC are equal. So just replace AD by DC. You can write because AD is equal to DC. Side of A square, DC square. Then AC square equal to what? You can write 2DC square. If you take out the square on the left hand side, then you will get here root over 2DC square. DC has a square, so you can take out this square. So square of DC square is DC. Means therefore we got AC equal to root 2DC. That means what? AC is the diagonal. Means diagonal is equal to root 2 into what? Side. You can use any in the case of any square. This one. Relation of diagonal side is what? Diagonal is equal to root 2 into side in the case of square. So now write this one here. So DC in the place of AC, what you can write? See, root 2 DC. Right, root 2 DC whole square. DC DC cancel. What is 1? So 1 by root 2 square is half. So this side area of DC is equal to area of what? ACF. Therefore, if you transfer ACF on the right hand side, area of DC is equal to half. It will be multiplied half into area of what? ACF. Proved. The area of this triangle is half of this triangle. See, area of DC is equal to half of area of ACF. Okay. In case any doubt, any confusion, please get back to me in the evening. Now, see your homeworks. Homework question number 5, 6, okay, and 9, 10. This 9 and 10 you can find out MCQ, okay. This is MCQ 9 and 10. So this 4 questions are your homework. So please submit in the evening. Thank you.